Okay, this is our C2 Chapter 2 checkpoint assessment. We're now looking at slides 7, 8 and 9. We've been asked to show sugar and water particles in a sugar solution. Now in this case, you should know that in a sugar solution, we expect the sugar to be distributed, okay, throughout the material. Okay, in the diagram, we've got blue circles representing the water particles and white circles representing the sugar particles. Well, if we're dissolving water sugar in water, we're expecting there to be more water particles than there are sugar particles. Okay, so if we take a look at our diagrams here, this diagram here looks a bit out of place because we've got a lot of sugar and not a lot of water. Here we're about roughly the same, so I'd suggest that we're going to look at these two here. We're expecting our sugar to be spread out throughout the solution. You notice here our sugar is not dissolved, whereas in this case our sugar has clearly dissolved. It's spread out fairly well, and so therefore our answer here is this one. Okay. Conservation of mass here, all this is a little bit of adding. We're going to make some solutions. We're going to dissolve, for example, 10 grams of salt in 105 grams of water. Well, if I've got 10 grams of salt and I've got 105 grams of water, I'm going to have 115 grams of solution because 105 plus 10 is 115. Similarly, 5 and 90, 95. 5 and 95, 100. And 5 and 100, 105. This question seems quite easy on the surface. Remember, what we're really thinking about is the concept here, which is that mass is conserved. That is, even when I dissolve things, the mass still remains there. And so even though your sugar or your salt appears to disappear, it's actually still there, and we know that because the mass is increasing. Last one, we're going to look at solubility. Okay, and we're told to look at the solubility at 30 degrees. So we need to be looking, although we have solubility changing all the time, we need to be looking at this 30 degrees point. We want to start with the least soluble substance at the top, and that way it means we're working from the bottom and following this line up. So the first one that we come to is this yellow, that's cerium 3. We've then got this light blue line, that's potassium chlorate. Okay. We've then got this red line, which is potassium chloride. Okay. After the red, we're going to brown, which is potassium nitrate. I've already got it there, fantastic. Then green. Okay, that's going to be my lead nitrate, good. And then finally dark blue, which is sodium nitrate. Noticing, obviously, as I've said, that the solubility changes with temperature. In the majority of cases, solubility is increasing with temperature. However, in the case of this cerium 3 sulfate, it's actually decreasing, so that would be an exception to our normally expected behavior.